Hi, this is Mrs. Rodriguez, your geometry teacher. This video is a review for the Chapter 8 test that's coming up soon. These problems are selected from a practice test that's in your textbook. It's on page 615. And also, there's might be a couple of extra problems in there that were not in the practice test, but will definitely be on your quiz. I'm sorry, on your test. Okay, so what I recommend that you do is that when a problem comes up on the board, try to pause the video, try to solve the problem on your own first. And then if you get the correct answer, great, move on to the next problem. If not, hopefully you can figure out your mistake based on my explanation. And if you go through the whole video and there's still a couple problems that you're still confused on and you can't figure out what your mistake was, please call, text, or email me or stop by my office hours, and I'll be happy to go over those problems with you in more detail. Okay? All right, so let's go ahead and get started. Okay, so like I said, this is a review for the Chapter 8 test that's coming up. And so the first lesson talks about the geometric mean. It says for two positive numbers, a and b, the geometric mean is the positive number x, where a over x is equal to x over b. So you're either going to do a over x is equal to x over b, which is equal to x squared, when you cross multiply, x times x is a squared, and then a times b is ab. And then when you have the opposite of squaring a number is taking the square root. So then x actually equals the square root of a times b. Okay? All right, so let's look at an example here. It says to find the geometric mean between each pair of numbers. Okay, so we have 14 and 21. So if we use that x is equal to the square root of a times b, and this 14 is a and 21 is b, then we have x is equal to 14 times 21, and we want the square root of that. And then when you multiply 14 times 21, that equals to 294. We want the square root of that. And there's a perfect square of 49 here. 49 times 6 is equal to 294. So we can factor out that perfect square. And then the square root of 49 is 7. So it'd be 7 times the square root of 6. And if we wrote that as a decimal, put that in your calculator, 7 times the square root of 6, you get 17 and 1/10 when you round it off, okay, to the nearest tenth. Okay? All right, let's look at the next problem. This one says to find x, y, and z. Okay, here's x, here's y, here's z. Okay, so first let's look at at x, okay? And it says, we're told this is when we have a right triangle and you have a line here, this is called the altitude. If it makes a 90-degree angle, that's called the altitude. And this triangle is proportional to this triangle, and both of those triangles are proportional to this larger triangle, okay? We also learned in this lesson 8-1 that the altitude can be calculated using the geometric mean, okay? And we would take the geometric mean of the length of these two sides here, okay? So again, we would find x is equal to the square root of a times b, okay? And we're using 9 for a and 4 for b. This is the geometric mean altitude theorem, okay? So then we end up with, we have the square root of, we multiply this. 4 times 9 would be 36, and then the square root of 36 is equal to 6, okay? So we've got x there, okay? So then there's also the geometric mean leg theorem. Okay, so let's try to find this here. So we're missing one of the legs of this triangle here. Okay, but the geometric mean leg theorem says we can take the length of the whole hypotenuse here, okay, and then the length of the leg that we're missing, okay, and that would be equal to the leg that we're missing over the part that you know, right? The leg that you do know the value of. So we'll put known leg value, okay? So we have, when we set up our proportion here, the whole would be 9 plus 4, which is 13. We're looking for y, okay? And then we know that this leg is equal to 4, okay? So then we would cross multiply here, and we would end up with y squared is equal to 4, the square root of 4 times 13. And we know this that the square root of 4 is equal to, the square root of 4 is equal to 2. And the square root of 13, we don't know that. We can type in our calculator 2 times the square root of 13, okay? Or we can just leave it like that, okay? 2 times the square root of 13, okay? And then we're going to solve for z. So again, we're missing one of the legs of this right triangle, but we know the length of the other leg. So again, we can use the geometric mean leg theorem. So we put the whole leg over the leg that we're missing is equal to the leg we're missing over to the leg that we know from this triangle here, which is 9, okay? So then we end up with z times z, which is z squared, and then we're multiplying 9 times 13. And we know that the square root of 9 is a perfect square, the square root of 9 is 3, and times the square root of 13, and we would just leave it like that, okay? All right, so next problem. Next section actually talks about the Pythagorean theorem, okay? It says, let triangle ABC be a right triangle. So this only applies to right triangles, okay? With right angle C, then a squared plus b squared equals c squared. So notice it said with right angle C. So here's our right angle, this is C. So this is going to be A and B. So C is always the hypotenuse. And if you look at the right angle, it's kind of pointing at the hypotenuse. That is always going to be C. A and B doesn't matter which value is A, which value is B, but C is the one that matters, okay? All right, so let's look at some of these problems. So here we have a right triangle. We're given 2 of the sides, and we're missing the hypotenuse, right? Because this right angle is pointing to that side. So we start with our Pythagorean theorem, a squared plus b squared equals c squared. We fill in what we know. I'm just going to put 10 as A and 24 as B. And we're looking for C, okay? So this would be 100 plus 24 times 24 is 576. Be a good idea to have a calculator, okay, when you're taking this test. So when you add this together, it's 676 is equal to c squared, and then you take the square root. You definitely want a calculator for these types of problems. I don't expect you to know the square root of 676 off the top of your head, and it is actually a perfect square, because 26 times 26 is 676. Okay, so C is equal to 26. Okay. All right, next problem. Now here, remember here is C right here. Now we are given C. We can call this A and we can call this B, or either way. We could have called this B and this A, whatever you prefer. Okay, so we have A squared plus B squared equals C squared. Okay, so we end up with x squared, because that's what we used for A, and then B is 38 squared, and C is 42. And we're squaring that. Okay, so we have x squared, and then 38 squared is 1,444, and 42 squared is 1,764. So then we're going to, oh, sorry, I put a equal sign here. That should be a plus sign. So then we've got an equation here. So I'm going to subtract 1,444 from both sides. And I end up with x squared is equal to 320. And then we would take the square root of both sides, and you end up with the decimal 17 and 88 So if we round this to the nearest tenth, it'd be 17 and 9/10. Okay? And that would be our final answer there. Okay, so now we have a word problem here. It says Blake is setting up his tent at a Renaissance fair. The tent is 8 feet tall. So we've got tent here 8 feet tall, and the tether can be staked no more than 2 feet from the tent. How long should the tether be? Okay, so tether is just something that helps hold up the tent there. So we have a right triangle. We know the lengths of two of the sides, so we know we're going to be using the Pythagorean theorem. Okay, so we can use, well, we have the right angle here, and it's pointing at this side here. So we're going to use x for C. So we can use 8 for A and 2 for B. Either way. Okay, so this would be 8 squared plus 2 squared equals x squared. That is what we are looking for. So 8 squared is 64. 2 squared is 4 equals x squared. So that's 68 when we add that together. And then we take the square root of both sides, and you end up getting the decimal 8 and 2400 is equal to x. So we're going to round that to the nearest tenth. So we have a 4 in the hundredths place. This 2 is going to stay the same. So 8 and 2/10, and this is feet. Okay. All right. So next problem. This next section actually talks about special right triangles. And this says the measures of the sides of a 45, 45, 90-degree triangle are x, x, and x times the square root of 2. And then the measures of the sides of a 30, 60, 90-degree triangle are x, 2x, and then x times the square root of 3. Okay? So here it says to find x and y. Excuse me. So here we have a 45, 45, 90-degree angle. And over here we have a 30, 60, 90-degree angle. Okay, so these are those special types of right triangles. So all we know right now is the value of this hypotenuse on the 45, 45, 90-degree triangle. So for the 45, 45, 90-degree triangle, the relationship is x, x, and then x times the square root of 2. Okay, so if we know that the 90-degree triangle is equal to 8, okay, and we know that 90-degree angle relationship is x times the square root of 2. So then what we're going to do is we're going to solve for x, and that would give us the length of both of these sides, and we're looking for x, so that's what we need. Okay, so what we would do here is divide both sides by the square root of 2 to isolate x. Okay, so we've got 8 over the square root of 2, and you're going to multiply by the square root of 2 over the square root of 2, and you end up with 8 times the square root of 2 over square root of 2 times the square root of 2 is square root of 4, which is 2. Okay, and then we can simplify. 8 and 2 have a common factor of 2, so 2 goes into 8 4 times, and 2 goes into 2 once. So we end up with 4 times the square root of 2 is equal to x. Okay, so now we know this here is equal to 4 times the square root of 2. Okay, so now we're going to look for the value of y. Okay, so we've got this 30, 60, 90 degree triangle, and we know that the value of y, corresponds to the 60 degree angle, so that would be x times the square root of 3. Okay, and we know the side opposite of the 30 degree angle, that is x. Okay, so we know that what we're going to do here to solve for y, the relationship is x times the square root of 3, and we know that x is equal to 4 times the square root of 2. Okay, so we're plugging in the value we just figured out for x, we're plugging that in for x, and then we're going to multiply that times the square root of 3. Okay, so we have 4 times the square root of 2 times the square root of 3, which is the square root of 6. Okay, and there's no perfect square there, so that's as far as we can go. So x is equal to 4 times the square root of 2, and y is equal to 4 times the square root of 6. Okay. All right, and then for this problem, number 19, it says, which of the following is the length of a leg of a 45, 45, 90 degree triangle with a hypotenuse of 20? Okay, so we know that the 90 degree angle is going to be, the relationship is x times the square root of 2. Okay, so if we know that that length is 20, we're going to set 20 equal to x times the square root of 2. Okay, then we're going to isolate x, and we're going to divide both sides by the square root of 2, and then 20 divided by the square root of 2, I need to multiply by the square root of 2 times the square root of 2, and that would be 20 times the square root of 2 over the square root of 4, which is 2. And then I can simplify here, because 20 and 2 have a common factor of 2, so 2 goes into 2 once, and 2 goes into 20 10 times. So I'm left with 10 times the square root of 2. Okay, and that would be b. Okay. All right, so clear this. So then the next section gets into some trigonometry, and it explains how you can use the sine if you know the opposite leg and the hypotenuse of an angle. And then you can use cosine if you have an angle and you know the length of the adjacent leg and the hypotenuse side. And then you would use the tangent if you knew the length of the opposite leg and the length of the adjacent leg. Okay, so this gets into the angles of elevation and depression. Okay, so here it talks about Sarah's cats. She climbed up a tree, so there's her little cat up here. And if she sights her cat at an angle of elevation of 40 degrees and her eyes are 5 feet off the ground, how high up from the ground is her cat? Okay, so you're looking for this whole, this length, and then you can add that to 5. Okay, so we know here we have our 40-degree angle, and you're looking for this value here. So that's the opposite over the adjacent angle. Okay, so that would be tangent. Okay, so the opposite, we don't know, that's what we're looking for. They used CB, and then the adjacent leg is 10 feet. So then to isolate this CB, you would multiply both sides by 10. So then you would have 10 times the tangent of 40. You put that in a scientific calculator, and you end up with 8.4. So that means the length of this is equal to 8.4, but it wants the distance from the ground all the way to the cat. So you would have to add the 5 to the 8.4. So her cat is 13.4 feet up. Okay. So then you have another problem here. It says Anna is watching a space shuttle launch 6 miles from Cape Canaveral, Florida. Okay, so we have Anna. She is watching a space shuttle launch 6 miles from Cape Canaveral in Florida. And the angle of elevation from her viewing point to the shuttle is 80 degrees. How high is the shuttle if it is going straight up? Okay, so the thing about these problems is you have to make sure that you're drawing your picture accurately. So here we have Anna, okay, and she is 6 miles away from Cape Canaveral, Florida, okay, and she's watching the shuttle. Let's see, she's watching the shuttle here, okay, and her angle of elevation, okay, is 80 degrees, okay. How high is the shuttle? So we want to know from here to here. That is what we're looking for, okay. So we've got the opposite over the adjacent. So that's going to be the tangent of 80 degrees is equal to x over 6. So then we would multiply both sides of our equation by 6. So we have 6 times the tangent of 80 is equal to x. Type that in a calculator. You end up getting pretty close to 34, and this is miles. Okay? So you got to be able to draw that picture accurately. So then here it says Isaac is looking through binoculars on a whale watching trip when he notices a sea otter in the distance. If he is 20 feet above sea level in the boat and the angle of depression is 30 degrees, how far away from the boat is the sea otter? Okay, so here we have the little boat, and here is Isaac, okay, and he's looking, there's a ocean there, and then he sees this sea otter in the distance there, poking its head out there, okay, and it says he is 20 feet, okay, he is 20 feet above sea level, okay. Okay, sorry about that. I was not drawing the picture correctly. Okay, so here we have the boat, okay, and then here's Isaac, and he's looking right out, and then he sees in the distance a sea otter, okay. There's the water there, okay, and then well, I guess I should put it. Okay, that's fine. So from where he is to the sea level, it's about 20 feet. I should have drawn sea level over here. Okay, there's the sea otter. So from here to here, this is 20 feet. Okay, and then the angle of depression, so from here to the sea otter, so angle of depression, this is line of sight, and then the angle of depression is here, 30 degrees. So this this angle over here would also be 30 degrees, okay? And then we have the opposite, the 20 feet, and then it's asking how far away from the boat is the sea otter. So it's asking for the distance from here to the boat, okay? So opposite over adjacent, okay? So opposite over adjacent is equal to tangent. So we need the tangent of 30 degrees, and then the opposite is equal to 20, and then adjacent is equal to x. So then what we would do is multiply both sides by x, and then we have x times the tangent of 30 degrees is equal to 20. And we want to isolate x, so we would divide both sides by the tangent of 30. And then we end up with x is going to be 20 divided by the tangent of 30. And when we put that into our calculator, we end up with 34.64 or 64 hundredths. So we would round it to the nearest foot. So that would be 35 feet. Okay. So x is equal to 35 feet. Okay. All right. So then it talks, next section talks about laws of sines and cosines. Okay. This is law of sines. Okay. And then law of cosines. Okay. So we're going to use each of these. Okay. So problem number 17, we're given the measures of two of the angles here. And a non-included side. So we're going to use the law of sines, okay? So we're going to say that the sine of 87 degrees over x, okay, that corresponds to that side, is equal to the sine of 37 degrees over 21, okay? So then we're going to cross multiply. So we've got x times the sine of 37, and then 21 times the sine of 87. Okay, we're going to isolate x, so we're going to divide both sides by the sine of 37. So x is going to be equal, when we put it in a calculator, we get 34.84, and it says to round to the nearest tenth. So we have 4 in the hundredths place, so we're the 8 in the tenths place is going to stay the same. So x is equal to 34 and 8 tenths. Okay. And then this problem here, it says to find x. Okay, so we're looking for x. we're not given the length of any, the measurement of any of the angles. So we're going to be using the law of cosines. So we're going to be using a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a, okay? And I'm going to label this triangle. This is going to be angle A, this is angle B, this is angle C. So that makes this C, this value B, and this value A, okay? So then I'm going to plug in my values here. So A is going to be 39 squared equals B, which is 59. We're going to square that. And then C, which is 36 squared, minus 2 times B, which is 59, times C, which is 36, times the cosine of A. Okay? So then this is 1,521 is equal to 3,481 plus 1,296 minus 2 times this 59 times 36 is 2,124. Definitely a good idea to use a calculator during this test for all this arithmetic that you have to do. So this is 1,521 is equal to, we're going to multiply this by 2. This ends up being 4,248. And I'm going to bring everything else down. Don't forget about that cosine A. And then this ends up being 1,521. We add these two together. And this is 4,777 minus 4,248 times the cosine of A. So we don't subtract this. We've got multiplication here. What we're going to do is subtract 4,777 from both sides. And we end up with negative 3,256, and then equals negative 4,248 times the cosine of A. And then to find the cosine of A, we're going to divide both sides by negative 4,248. So we end up with positive, negative divided by negative is positive, 3,256 over 4,248 is equal to the cosine of A. And then we're going to use the inverse law of cosines here. So that means that, let me change colors here. The measure of angle A is going to equal to the inverse of cosine of 3,256 over 4,248. Okay, so you can put that in calculator, and then you end up with 39 96/100, and it's asking you to round each angle to the nearest degree. So then the measure of angle A would be 40 degrees. Okay. All right. Next problem talks about vectors, and a vector is a quantity with both magnitude and direction. Okay, so it says, this problem says to write the component form of each vector. So to write the component form of a vector with initial points xy, x1, y1, and terminal point x2, y2, what we need to do is find x2 times, x2 x2 minus x1 and y2 minus y1, okay? So our initial point is B, okay? So our initial point B, the coordinates are -2, -2, okay? And then our terminal point, which is our ending point, which is C, the coordinates are 4, +4, +1, okay? So we've got the x value of our terminal point, which is 4, minus the x value of our initial point, which is -2. And then we're going to take the y value of our terminal point, which is 1, and then subtract the y value of our initial point, which is -2. So remember to add the opposite. So this ends up being 4 plus +2, so that's 6. And this ends up being 1 plus 2, which is 3. So our component form of the vector is 6, x is 6 and y is 3. Okay. All right, and that's all for the review for the Chapter 8 test. Hopefully this video was helpful to you. If you have any questions, please let me know, and I will be happy to help you if you got stuck on any of these problems or didn't understand the explanation. Okay, hopefully it was helpful, and good luck to you on your test. Have a good day.